In this video, we're talking about the slope of a line, and we need to talk about what we mean when we say slope of a line. Well, the slope is basically how fast y is changing compared to how fast x is changing. How fast do I move along the y-axis compared to how fast do I move along the x-axis? Oftentimes you'll hear it called rise over run. Rise meaning how fast do I go up, what's my change in y? Run meaning how fast do I go out along the x-axis, how fast do I go horizontally compared to vertically. So how do we define this mathematically? Well, we usually use m to define the slope. M means slope. And m is going to be equal to the change in y over the change in x. This little triangle is called delta. It's the Greek letter delta, and it's what we use to describe change. So this just means change in y over change in x. How fast is y changing compared to how fast x is changing? Well, if we look at a couple of these lines, let's look at the orange line here. We can figure it out pretty easily. We can say m is equal to, and here if we look at the orange line, let's take this point right here. At this point, x is equal to 0, right? This is along the y-axis, so that means x is equal to 0, and y is equal to -1. So this is the point 0, -1. At this point here, which is also on the orange line, x is 1, because we're out a distance of 1 along the x-axis, and y is 0. Since we're right on the x-axis, y is 0. To get from this point on the line to this point on the line, how far do I have to go up along the y-axis? Well, I just have to go up 1 unit. I go up 1 unit, so my change in y is 1. Since m is change in y over change in x, I put 1 in the numerator because my change in y is 1. That gets me from this point here to the origin. Now, how do I get out to this point? Well, I have to go 1 unit in the positive direction of the x-axis. In other words, I have to go over 1. So my change in x is going to be +1. So m is equal to 1 over 1, or just 1. Therefore, the slope of this line is going to be equal to 1. And I can apply that anywhere on the line. So if I start at this point, 1, 0, I want to go up to this point here. I go up 1 unit and over 1 unit, and I arrive at this point. And that'll continue to hold. Up 1 unit, over 1 unit, up 1 unit, over 1 unit, and I can go the other direction. So if I start at this point, and I want to get to this point along the line, I go down 1 unit and then over 1 unit this way. So that brings up an important point. Here's what we need to realize. We said that the slope m was equal to +1. That's what we simplified 1 over 1 to. We got +1. Well, what we need to realize is that +1 can be 1 over 1, +1 over +1, but it can also be -1 over -1. In other words, when I take -1 divided by -1, my negative signs cancel and I get a +1. So these things are all equal. What that tells me is that not only can I go in the positive direction of the y-axis 1 unit and the positive direction of the x-axis 1 unit, in other words, +1 over +1, but I could do -1 over -1. I can go down in the negative direction of the y-axis 1 unit and then over to the left in the negative direction of the x-axis 1 unit. So -1 gets me to another point on the line. Now, sometimes you're not going to be given a graph of the line. You're not going to be given a picture. You're only going to be given 2 points on the line. If that's the case, how do you find the slope? Well, let's use an example here. If we were given the points 0, -1, and 1, 0, we could use those to find the slope of the orange line, because m is equal to the change in y over the change in x, and it's also equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. In other words, if we call 0, -1 the point x sub 1, y sub 1, and we call 1, 0 x sub 2, y sub 2, then we can just plug into our formula here. So what we would get is m is equal to y sub 2. We find the y coordinate from x sub 2, y sub 2, which is 0 right here. So we say 0 minus, and then the y value from the other coordinate point, x sub 1, y sub 1. Y sub 1 is -1, so we get -1. Then we divide that by x sub 2, which is right here. We know that that's 1. And then we subtract x sub 1, which we know right here is 0. When we simplify this, 0 minus a -1 is the same as 0 plus 1. 1 minus 0 is 1. 0 plus 1 in our numerator is 1, so we get 1 over 1, or 1. So that's what we found earlier using just the picture of the graph, but we can also use this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, if we're only given 2 points on the line and we don't have a picture to work with. Let's do a couple more examples really quickly. Let's look at our green line here. We have this green line. We know we have the point 0, 0 at the origin. We also have this point here, so let's just go ahead and say 0, 0. We also have this point here, 1, 2. This is 1, 2 because we're out along the x-axis 1 unit, up along the y-axis 2 units, so we're at 1, 2. We could say that our slope m, therefore, is 2 minus 0, the y-coordinates, over 1 minus 0, the x-coordinates. That's going to be 2 over 1, or just 2. And I can see that that's true because I want to go up 2 and over 1. In other words, up 2 here and over 1 here. If we compare the orange and the green lines, what we can say is that the green line is steeper than the orange line. The change in y is 2 units for every change in x of 1 unit, versus the orange line here, the change in y is 1 unit for every change in x of 1 unit. So the green line is going up faster than the orange line is going up. So the green line is steeper. And what that tells us is that since this is equal to 2 and the slope of the orange line is equal to 1, the larger the slope is, the steeper the line. So because 2 here is greater than 1, we know that the green line is going to be steeper than the orange line. If we had a slope of 1/2, because 1/2 is less than 1, the line would be more gradual, it would be less steep than the orange line. So it would be something like this, more shallow here than the orange line. What about if we look at this blue line here, this teal line? This is pointing in exactly the opposite direction. If we try to find the slope here, what we can see is we have this first point here, which is at 0, +1. Then we have a point over here, which is at +2, 0. If we use our slope formula and we take our y-coordinates and subtract them from each other and we say 1 minus 0, 1 minus 0, and then we take our x-coordinates and subtract them from each other and we get 0 minus 2, 0 minus 2, what we get is 1 over -2, which we know is equal to -1/2. Now this brings up a couple of important points. The first one is, and you may be wondering this, does it matter which point is x sub 1, y sub 1, and which point is x sub 2, y sub 2? And the answer is no, it doesn't matter as long as you keep it consistent. So if you use this value of y for y sub 2, then this has to be x sub 2. You can't have y sub 2 mixed with x sub 1. So you always want to start with one point and then subtract the values from the other point. So we'd have to start with 1 and do 1 minus 0, and then start with 0 and do 0 minus 2. Or we could start over here and we could say for the y values 0 minus 1, and then start over here and for the x values say 2 minus 0. It doesn't matter which way you do it, you'll get the same answer every time as long as you keep it consistent. And one point is x sub 2, y sub 2, the other point is x sub 1, y sub 1. So now the second important point we realize when we calculate the slope for this teal line here is that we found a slope that was negative. The other two slopes were positive numbers. And here's what this tells us. If our slope is negative, then our line is going to lean to the left like this one does. If our slope is positive, our line is going to lean to the right like the green and orange lines do here. So when you see a negative slope, you know it's going to look more like this one. When you see a positive slope, you know it's going to look more like these two. And what we need to realize is just like we set up here that +1 was equal to +1 over +1 or -1 over -1, when we get a negative slope, we can say that that's going to be equal to a +1 over a -2 or a -1 over a +2. You can put the negative sign with the numerator or with the denominator. Both of them will give you that negative slope. And that's important because if we use +1 over -2, it tells us that, let's just say we start from this point here, that we're going to go up 1 in the positive direction of the y-axis and then over 2 in the negative direction of the x-axis because we have a positive y and a negative x. So we go up 1 and over 2, up 1 and over 2, and that gets us this direction. But if we start from this point and we use -1 over +2, then we have a negative y and a positive x. So that tells us go down 1 unit in the negative direction of the y-axis and then over 2 units in the positive direction of the x-axis. So down 1 over 2, down 1 over 2, and that gives us this side of our line. So you can put that negative sign in the numerator or the denominator to get you two different fractions that you can use to draw the line.